In this video, I'll tell you about the concept capacitance. Now, I'll give you an example, and with that, I'll deliver you the concept of capacitance. What does that word means? Okay. We have two different tanks, water reservoir. One is in this way and other one is in this way. Which one is having higher capacity? Obviously, this one is having higher capacity. How can I define it scientifically? I can say in this way, with an axis, with an axiom or with a standard taken as to raise the water by 1 centimeter, the amount of water when we compare in these two tanks. For example, here, when I am raising the water level by 1 centimeter, the water capacity or water stored is 10 liter. But here in this case, it is stored, the amount of water stored is 1 liter. Okay, so I have defined the capacity as the volume stored when there is a rise in water level measured as 1 centimeter. Similarly, when we are storing charges, let's say in the case of sphere, I am keeping on storing charges, positive charges. Whenever we are increasing the charges here, there is a rise in potential. So now capacitance has been defined as the charge required to increase the potential by 1 volt. So Q by V. Okay, simply when V is 1 volt, that is the charge measured, that is nothing but the value of capacitance. So capacitance is nothing but charge required, charge added to the system to increase its voltage by 1 volt. So in certain system, we can add maybe 10 coulombs to increase 1 volt. In certain system, to increase 1 volt, we can only add 1 coulomb. So the one where we have added more number of charges has got higher capacitance. Now this is the equation: C is equal to Q by V or Q is equal to CV. This is very important relation. Now for a spherical substances, we will find out how to get the value of capacitance. Okay, now for a spherical ball, we already know what is the value of potential. V is equal to, you can use the equation E into D, or we already have find out the value of potential for a spherical shape. What is that? 1 by 4 pi epsilon 0 into Q by R. If at all, if you don't know, you can use the standard equation where you are very familiar with value of E. What is that? 1 by 4 pi epsilon 0 Q by R square is the value of E, and here the radius is nothing but R. Multiply it in this way, you will be getting the value 1 by 4 pi epsilon 0 Q by R. So next time onwards, without doing in this way, you should be able to get the value of potential on the on the surface of a sphere as 1 by 4 pi epsilon 0 Q by R. This we have learned. Now, how to get the value of capacitance? It's very easy. Capacitance is Q by V. So I can keep Q here. I can keep V to this side. So keeping Q here, taking V to this side, and everything to the other side. So this will be Q divided by V. I can take everything this side, 4 pi epsilon 0 R. This is an important relation. Capacitance of a sphere, a metal sphere, will be nothing but C is equal to Q by V 4 pi epsilon 0 R. Now we will see, is there any limit to which we can store charge in a sphere? So whenever we are storing charges, what happens? The electric field around the sphere increases, right? Now see, surrounding to the sphere, what we have? We have air particles. Air particles, right? So air particles are basically uncharged or neutral. Now whenever these charges are getting increased in the sphere, this field will become higher and higher and higher. So what will happen in an air particle? This is air particle. We have positive and we have negative. Now this field will, whenever it gets increased, this field will try to attract the negative charges. So whenever this field is very strong, these electrons, will jump and this will come to this. What will happen to this air particle? That has become ionized. Now when this happens, next particle will also go in the same way. So this electron will come here. So this also will become positive, 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 and this will continue. This is called as ionization. Whenever air gets ionized, that will become a conductor. So there will be a discharging. So this is called as dielectric strength. Okay, so we can only store charges in a sphere till its dielectric strength. After that, what will happen? After that, the surrounding will become ionized and that will result in neutralization. So what is neutralization? See, whenever this takes an electron inside, the total charge will reduce, and in this way discharging will occur. So this is the process of lightning. Clear? So till ionization we can store charge till dielectric strength, and after that we can't do that because the dielectric that surround the material will become ionized and that will act as a conductor and discharging will occur. Clear? So this dielectric strength will be different for different material. So in air medium, so when we are keeping our metallic sphere in air, it will have a different capacitance. When we are keeping it in a different substance, for example inside water, it will have different capacitance. Inside an oil, it will have different capacitance. And so capacitance will also, that depends on the value of dielectric strength that surrounds the material. Thank you.